You may have heard the phrase canaries in a coal mine. It comes from the practice when miners would bring canaries down into the mines underground with them and use them as sentinels or guardians of carbon monoxide exposure. Canaries are more sensitive to carbon monoxide than people, so if the canary showed sign of distress, the workers knew to get out of the mine as fast as possible before they were next. Well, our research follows the same theory, that animals can help us detect environmental dangers to people. So today I'm going to tell you about our research into toxic chemicals in the environment, cancer risk in dogs, why it matters to you, and things that you might be able to do to protect yourself and your pets. This is Maggie, my current boxer dog, and I've had boxers since I was 5 years old, and I'm in love with them. I'm imprinted on them. They're ugly cute, they're super affectionate, they're wiggly, and they're sometimes very naughty, which I also like. And boxers are essentially the court jesters of the dog world, and mine make me laugh every day. But boxers have a high risk of certain cancers, and when a sick boxer walks into a vet clinic, we veterinarians always have cancer on our list. So even though I know it's risky as a dog owner, I still love boxers, and I'm very motivated to understand why they get so much cancer. So in people, some cancers are caused by a single mutation in DNA, like the BRCA1 or BRCA2 genes in women that can lead to breast cancer at a young age. But most cancers in people are not caused by a single gene mutation, but instead are caused by an interaction between genes and our environment. So they're not driven directly by the DNA that we're born with. So most cancers in people are driven by our behaviors, either smoking or using tanning beds or drinking too much alcohol. Other cancers are associated with environmental exposures that we don't have a lot of control over, like toxic chemicals in the workplace or in the air or in water. So as a veterinarian, I'm interested in the fact that dogs get some of the same cancers that people do, and these cancers look the same under the microscope and behave the same way in the patient, whether it's a human or a dog. And two examples of these cancers are bladder cancer and lymphoma. And lymphoma is a cancer of the white blood cells. So these two cancers are more common in certain purebred dogs. So lymphoma is more common in boxers, and bladder cancer is more common in Scottish Terriers and West Highland White Terriers. And even though these cancers are associated with certain dog breeds, we still don't understand why some dogs in that breed are affected and others are not. We haven't found any major inherited gene defects driving these cancers in dogs, like the BRCA1 gene in people. And dogs don't smoke, they don't work in factories, but they may be exposed to toxic chemicals in the home. So how would chemicals in the home explain a higher risk of lymphoma in a boxer or more bladder cancer in a Scottish Terrier? Well, one possibility is that certain dog breeds are not able to break down these chemicals or neutralize them after they enter the body. Another possibility is certain dog breeds don't have the machinery to repair DNA after it's damaged by these environmental chemicals. And both of those would be in their DNA, but it wouldn't be directly driving the cancer. It would require exposure to the chemical for us to see it. So it's sort of like a person with a genetic risk for peanut allergy. The risk isn't recognized and it's not dangerous unless the person is actually exposed to peanuts. So I'm a scientist with research training in how the body breaks down drugs and chemicals. And I'm also a veterinarian who has diagnosed really more cases of lymphoma and bladder cancer than I care to recall. And finally, I'm a dog owner who has lost 3 of my beloved, wonderful boxers to lymphoma. And so that's why I do what I do. Our research focuses on the intersection of breed risk, which should be genetic, and environmental exposures for lymphoma and bladder cancer. And we're really interested in toxic chemicals in the home and yard. If we can understand what these chemicals are doing, we may better understand what causes these cancers in dogs and have better approaches to prevent them. We also may be able to prevent toxic chemical exposures in the people that share the same homes as these dogs. So let's get to our research. We first did a study to see whether healthy dogs and people actually are exposed to the same toxic chemicals in the home. We measured several environmental chemicals in the urine of more than 40 dogs and their owners, and we were really surprised to find out that we detected arsenic, which is a toxin, an air pollutant called acrolein, and a weed killer breakdown product in the urine of all the dogs and people that we tested. And all these chemicals have been linked to bladder cancer in people, so this finding was a little scary. We also found that levels in dog urine were 2 to 6-fold higher than levels in their owners. This could be because dogs are smaller than people, or it could be because of dog behaviors, that they go outside and roll in the grass, or come inside and rub on the rug and then groom themselves. Another interesting thing that we found is that if a dog had a high level of one of these chemicals, then their owner was more likely to have a high level as well. So that means that dogs and people are exposed to the same toxic chemicals in the home, possibly from the same sources. If these toxic chemicals are causing cancer in dogs, then dogs that get bladder cancer and lymphoma could be acting as canaries in the coal mine to identify households where people are exposed to higher levels of certain toxic chemicals. So how would this help us understand cancer in people? Well, dogs and people usually get lymphoma or bladder cancer when they're older. Dogs get these cancers when they're about 10 years old, and most people get these cancers when they're 65 or older. Because dogs have a shorter lifespan and everything happens much faster, it may be easier to see a direct link between a chemical exposure and the beginning of cancer in a dog than in a person. And this may help us identify chemical exposures in people before they go on to cause the same cancers. So instead of canaries in the coal mine, you might say that our research is really about boxers in the backyard. Now, we're not saying that if you have a dog with cancer that you're going to get that same cancer. But a cancer diagnosis in your dog may be a light bulb for you to evaluate what's around you in your home and yard, and maybe make some changes in your household that might protect your family and other pets. And our research is designed to help you figure out what those changes should be. So we did that study in healthy people and dogs, but we are also actively studying dogs with lymphoma and bladder cancer. Just to be clear, we're not causing cancer in dogs. We're not giving chemicals to dogs. We partner with owners of dogs that already have cancer and then try to figure out why those dogs got cancer. So let's start with boxers in the backyard. We're studying why dogs get lymphoma because it's a very common disease in dogs and is typically fatal even with chemotherapy. Lymphoma in people is associated with industrial areas and certain pollutants and some herbicides, and we suspect the same is true for dogs. With cancers caused by the environment, there are really 3 sources of risk. One is the exposure itself. Were you in contact with the chemical, whether you knew it or not? Whether your body is able to defend against the chemical, so can it break down the chemical or neutralize it? And then if the chemical does damage you, is your body able to repair the damage? So for example, fixing changes in strands of DNA so that the DNA goes back to normal. So for lymphoma in dogs, we focused on the first 2 layers of risk, exposure and defense. And we focus on boxers because they get a very aggressive form of lymphoma. And by looking just at one breed, it might be easier to see the role of the environment. So we studied more than 50 boxers with lymphoma enrolled from all over the country and more than 80 unaffected boxer dogs that were older. And we asked owners to fill out a questionnaire about the use of weed killers and paints and paint strippers, new carpet or flooring, and where they walked with their dog, near gas stations or railroad tracks, farms, or golf courses. And we looked at the dog's home address and the county that the dog lived in, and we looked at Environmental Protection Agency or EPA data and compared water and air pollution levels in the places where dogs with lymphoma lived to the places where dogs that did not get lymphoma lived. We also took a cheek swab from these dogs and isolated DNA and looked at whether these dogs with lymphoma had specific gene abnormalities in an important chemical defense pathway, and this is called GSTs. And these enzymes are in your body, and they help you break down and neutralize chemicals after you're exposed to them. Now, we didn't find any differences between the dogs with lymphoma or the unaffected dogs in these GST genes, but we have more work to do in that area. But we did find that boxers with lymphoma were more likely to live within 2 miles of a crematorium, and these crematoria emit a lot of particulate air pollutants, chemical suppliers, or within 10 miles of an active nuclear power plant. We also found that boxers with lymphoma were more likely to live in counties that had higher levels of ozone, which is a marker of air pollution. So ozone is we think of ozone as being protective on the Earth's in the Earth's atmosphere, which it is. But ozone down near where we live is a marker of air pollution because ozone is generated when certain chemicals in air pollution break down. We also found that boxers with lymphoma were more likely to live where there was a lot of formaldehyde in the air and a chemical called butadiene. And these chemicals are what we call VOCs, or volatile organic compounds. You may have heard that term before. And these VOCs have been linked to lymphoma in people, and we found that they were also linked to lymphoma in dogs. So we're now enrolling boxers with lymphoma to directly measure some of these chemicals in the dog's urine and compare that to boxers that aren't affected by lymphoma. We give the owners a special kit with a special wand they can use to collect urine so they don't have to get down on their hands and knees. And we're also measuring chemicals in the dog's homes. So we give the owners a kit where they can use special tubes to collect their drinking water, and that lets us measure a bunch of different chemicals in the drinking water. And we give them this really cool special canister that they can put on their kitchen counter and open the valve and collect air throughout the day, close the valve, and send it back to us, and we can measure indoor air pollution. So our goal is to identify one or more chemicals in the home that are directly linked to lymphoma in dogs. And our hope is that this will allow veterinarians to give owners of high-risk dog breeds clear advice on what to avoid, be it herbicides, unfiltered tap water, or paints and construction materials that contain these VOC chemicals. And this research is ongoing, so we need your help. If you have a boxer with lymphoma or know someone with a boxer with lymphoma, please help us meet our goals and join our study. So we're also studying risk factors for bladder cancer. Bladder cancer in people can be caused by smoking or industrial exposures at work, but about a third of bladder cancer cases aren't explained by tobacco or occupation. Some studies have linked these bladder cancer cases to weed killers, air pollutants, or water contaminants, but it's still not clear in people. And we wanted to look at whether these chemical risk factors were in play in dogs. We enrolled more than 60 dogs with bladder cancer and older dogs of the same breed and sex that did not have bladder cancer. We again looked where the dogs lived, their home address, and what was around their house using Google Maps. And we looked at their counties and looked at EPA air pollution and water pollution data for the county they lived in. We also asked owners to report the use of weed killers, insecticides in their home, the source of their drinking water, the amount of drive-by traffic near their house, whether they had a treated wood deck, which can have arsenic in it, and whether there were smokers in the home. And we found that dogs with bladder cancer were more likely to live in a home with insecticides, although I don't think we did a very good job with the questionnaire in helping people distinguish between an insecticide, which kills things like ants and fleas, and an herbicide, which kills weeds. So we've revised our questionnaire going forward. We also found that dogs with bladder cancer were more likely to live in a county with higher levels of air pollution as measured by ozone. And they lived in areas with more than threefold higher concentrations of a drinking water contaminant called total trihalomethanes. And these are breakdown products of chlorine and other water disinfectants. Now we have to disinfect our water so we don't get E. coli or cholera, but different sources of tap water have different levels of these breakdown products. Now, these were associations we saw by asking questions and looking at data. So now we're directly measuring these chemicals in the urine of dogs with bladder cancer and comparing them to the urine of similar dogs that are not affected by bladder cancer. And again, we're measuring chemicals in the house. So we're using special tubes to check the tap water for arsenic. We're measuring acrolein in kitchen air, and we're measuring arsenic in dust in the household. So we give the owners a little paper template. They put it on the floor, use a special dust wipe to pick up dust from a 1 foot square area of the floor. We send it back to us and we can measure arsenic in the dust in the house. We also have an option for owners to submit their own urine, so we can see that whether a person who lives with a dog with bladder cancer has higher levels of certain chemicals in their urine than a person that lives with a dog that didn't get bladder cancer. So these studies are important because direct measurements of chemicals are more powerful than a questionnaire. So in some cases, you might not know what chemicals are in or around your house. It's possible that you or your dog are exposed to chemicals that you don't even use in your home. So for example, we know that wind can blow pesticides from a golf course or a farm onto your property. We know that if you're walking through herbicides at the dog park, you can track them into your house. And you could live in an area where your tap water is less than pristine. So this research is also ongoing, and again, we need your help. If you have a dog with bladder cancer, or you know someone who has a dog with bladder cancer, please contact us to join our study. So our hope is that this research will help veterinarians and dog owners. We want veterinarians to be able to ask the right questions about environmental exposures when they've diagnosed a dog with lymphoma or bladder cancer. And we want to be able, as veterinarians, to provide accurate cancer prevention advice to you as owners of dogs, and particularly to owners of high-risk dog breeds. For example, if we were to find that arsenic in tap water was a risk factor for bladder cancer in dogs, we could very strongly recommend to owners that they buy a particular water filter. If we found that urine levels of herbicides are associated with lymphoma in dogs, we could strongly advise dog owners against specific lawn products. And on a larger scale, these findings could spur dog owners to support new policies and legislation to protect the health of both animals and people. So until we know more, here are some practical tips for you and your dog. Stop using herbicides on your lawn. Let go of the need for a perfect lawn. Not all lawn care chemicals are harmful, but weed killers are strongly linked to lymphoma and bladder cancer in people. When studies were put together and they looked at a bunch of different studies, the link between 2,4-D, which is a broadleaf herbicide that people will put on their lawns to kill the dandelions and not the grass, was linked to bladder cancer. And glyphosate, which is in Roundup, that people use to sort of spot treat dandelions or to kill an area of grass before they make a garden, also linked to lymphoma in people. So ask yourself if the benefit of a perfect lawn is worth having these chemicals on your property. Secondly, when you're off your property, walk your dog on ugly, not perfect grass. So this is my mantra when I'm out walking my boxer. There's a good reason for it. So picture perfect lawns or parks that have no weeds have definitely been treated with weed killers. So walk your dog in parks that have weeds. Take your shoes off when you come into your house. This is customary in so many other countries, but not so much in the United States. Pesticides can get tracked into your house and end up in household dust. And these chemicals could end up inside your dog if your dog rolls around on the floor and then grooms their fur. Consider a water filtration unit for your tap water, and one that removes lead, arsenic, and these total trihalomethanes, or byproducts of disinfection and chlorination. And finally, if you're painting your house, choose low VOC or low volatile organic compound paints that don't off-gas and smell and release these toxic chemicals. And choose low VOC building materials if you're doing any renovations in your house. But finally, remember that good is better than trying to be perfect. And there's no way we can completely protect ourselves and our pets from the environment. So we have to do the best we can with the choices that we have. And as a researcher, I will do my best to keep generating good scientific evidence to help you do the best you can.